In this second video, we look at a collection of real numbers and ask the question as to whether they are transcendental or not transcendental. By now you should have downloaded and printed the PDF document of the questions, have something to write with, and at the end of each question you might want to pause the video to decide on your answer and to make a note of it, and then continue the video to the next question. So for each of the following real numbers, you are to classify them as either transcendental or not transcendental. If they are not transcendental, it means they are algebraic. Recall that irrationals that are not algebraic are solutions of polynomial equations with rational coefficients. And we call these transcendental numbers or transcendentals. So a transcendental is a number which is not a solution of a polynomial equation with a rational coefficient. If it's not transcendental, it means it is a solution of a polynomial equation with rational coefficients. We call it algebraic, and it could either be rational or still irrational. So for question 1, here is an infinite series with alternating signs whose denominators are squares of odd numbers. Is this transcendental or not transcendental? Is it the solution of a polynomial equation with rational coefficients, in which case it's not transcendental, or is it not the solution of a polynomial equation with rational coefficients, in which case it's transcendental? For the second question, we have an infinite series whose denominators are natural numbers cubed, which can be written in two alternative forms. Is this transcendental or not transcendental? In this case, we have 4 examples of an infinite series whose denominators are powers of natural numbers, where the powers are either 5, 7, 9 or 11. Do you think this set of numbers for each of n equal 5, 7, 9 and 11 are transcendental or not transcendental? What about 2 to the power pi? Is that transcendental or not transcendental? What about pi to the square root of 2? Transcendental or not transcendental? What about pi divided by e? What about the natural logarithm of pi, ln pi? What about e to the power of e? Pi to the power of e. Both are transcendental numbers. What about the power of one transcendental number to another transcendental number? Is that transcendental or not transcendental? What about the sum of those two numbers, pi plus e? What about their product? And finally, what about e to the power pi? So again, the power of one transcendental number to another, as we've seen before, but in reverse. Not pi to the e, but e to the pi. Is that transcendental? So the solution of a polynomial equation with rational coefficients, which would make it not transcendental, or it's not the solution of a polynomial equation with rational coefficients, in which case it is transcendental. We could also ask the question, if it's not transcendental, which means it's algebraic, is it rational or irrational? Now watch the next video to find out the answers.